Okay, the next thing we're going to do here is continue on with our disassembly, and as we're disassembling we're looking for leaks, etc. We're looking for problems going in. A lot of people, this is the fan cover. A lot of people make a big deal out of how do I get this dang thing off. It's really very simple. There are 3 clips on it, and I'm going to tilt the engine just to show you one of them. The clip has a little depression that goes down into this casting, and all you have to do is put a flat tip screwdriver behind it and pry it out. See that? See how it moved? Same way under here. You just simply pry it out and then pry it forward. Over here we have one more. We pry it out and we simply pull that off. And there you have the fan, which again we talked about. It has an odd number of blades. You need that fan tool simply to fixate the fan, okay, to take this nut off. Okay, if you hold it by the blades can snap off. This fan is over $80 new, and they're hard to find used because everybody's bought them up. Because this tool here costs you $14 and some odd change. In my belief, it should come with the tool kit that comes with your engine. It doesn't. I keep them in stock. They're always for sale because it's my belief every owner ought to have one. We're going to go ahead and check the fan for tightness. I can tell by looking here, and you may be able to focus in there, that we have some dark discoloration right in here. Okay, can you kind of make that out? That is simply rubber. This fan, if you look, is extremely loose. It goes in and touches the metal, which has caused that rubber to come off. Probably the fan belt is going to have to be replaced on this one. There are shims that go between the 2 halves of the fan back here, or the 2 halves of the pulley behind the fan, that will make it thicker or thinner, thereby making the belt tighter or looser. As you thin the pulley out, it makes the belt tighter, and as you thicken the pulley up, it makes it looser. Another thing we want to pay particular attention to is look at all the rust that's on the outside of the crankshaft. That's the actual crankshaft inside the nut, and it is covered with pitted rust. We hope we're not going to find that internally. Okay, once we remove the exhaust manifold, the shroud, this half of the shroud on a 503, this is a 503 by the way, will just simply pop off. You should find 2 gaskets inside here and 2 gaskets outside. There is one missing right there. So we look at the manifold, and lo and behold, there it is. It stayed on the manifold. Never reuse the intake, exhaust, base, head gaskets. Replace them. They don't cost that much, and you're going to have a more reliable engine. Again, this goes down in the cart just for safekeeping. We're going to tilt the engine back here a little bit. If you look and can see all of the carbon, let me find a place. All of the carbon that's inside that wall and inside this one, you can see how thick that carbon is. See that lip of carbon in there? It's over 20 thousandths thick. If you notice, there's some brown below the rings. This is an indication that you're getting blow-by, that your rings are no longer working properly. At this stage, we have simply turned the engine around. Now we're going to move the intake. Again, starting from the outside. Okay, once you get those 4 screws out, you can simply pull that off. From the dirt here, this engine was never cleaned properly. Can you see all that dirt, all that dust? And that's also an indicator that that base gasket is leaking because it looks wet. It has a wet appearance. Okay, at this stage we're going to start disassembling the cylinders. Just because I would like to see what kind of pistons and etc. we've got in there. My air tool is going to get going here. I'm just going to pull the head bolts off. There's 4 in each head. I've got all of 3 of the nuts loose, and what I want to show you here is the way that most people strip either their nuts or the cylinder studs is on a 503 especially. The gasket is inside of the bolt pattern, the head gasket. And if you tighten one down too tight, you can actually over tighten it to the point that when you tighten the opposite one, it will strip it. As I tighten this, watch how it starts to lift the head. So this one is hand tightened, but now when I put this one on and tighten it down, it's going to strip this one back here. And let me see how that moved? So when you're putting these on, you want to take them down just to where you touch metal and back it off 1/8 of a turn. Okay, until you've got all 4 down like that. Then you just give them the tiny tweak till they just barely touch metal and it won't tilt the head. Okay, at this point is before I start disassembling the components from the engine. I want to make sure that this head stays with this cylinder, which stays with that piston, which I'm going to put a P on there with a scribe. I've marked that for a PTO. It's got a P on it. I simply remove that. On top of here, I put another P. And that can be removed. And I want to be careful here that I don't drop a bunch of junk down into the crankcase. Okay. And I keep these 2 together, which I will do as soon as I dump my washers and nuts. You can see from right here, he had a head leak. That's an indication of a head leak. It was definitely worse on one side than the other, and it may have been caused by somebody not knowing about the tilting of the head and tighten this bolt first. If you notice, there are grooves in the head. This is the reason you replace the head gasket each time, is it puts grooves into the head gaskets. I don't know if you can see those, but I can feel them. And those grooves fit up into the they compress into those cuts in the head and actually act as a better seal. Okay. This one, again, I knew it. It came from an aftermarket shop. This head gasket is made out of aluminum. Let me show you what I'm talking about. See how that thing just, one pinky finger and you can bend it. It's aluminum. A true aircraft head is made out of steel. And to accentuate this point, let me just show you this. Follow me over right above the garbage can here. This has a magnet in the end of it. We're going to put it on there and it's not going to hold it. Okay. Whereas a true head gasket, you take a magnet and it sticks to it. It's made out of steel. This is all aftermarket gasket stuff, which is why it's part of why it's leaking. Part of why the head was leaking. Some people say it doesn't make any difference. Well, they wouldn't make it different if it didn't make a difference. Okay. This is a good shot here of what we were talking about as far as blow-by. See how brown it is turned below the ring? That's an indication that the flame is blowing by the ring, which could mean that your rings were wore out. It could mean that these are aftermarket rings somebody's put in there. It could be that there were rings taken off of other pistons. You don't know when you go to an unauthorized shop. There's very little carbon built up on top, so my best guess is this was probably decarbed and sold to him as just being decarbed, you know, so many hours after decarb. This is normal amount of carbon for inside the head. It's not any kind of thick plating. It's simply just starting to turn it black. Another thing we want to look at here quickly is we were talking about the hone marks. If you look through this exhaust port, and focus in there as best you can, it's a little hard to see, but these are not crosshatch marks. They are just spun marks. They're just going around in a circle. Crosshatching should go at an angle, at about a 45-degree angle. Okay. Another thing you can notice here is at the bottom of the cylinder. It's just been spun. Nobody has bothered to put the proper crosshatching in it. On this side you can actually see the wear. Move my hand there. You can see where there's some vertical scratches, but there's no cross hatching. If you know what cross hatching is, there is none. This engine should have been cross hatched before it was put back together. It should have also been cleaned, and it could have been, but if you look here, that is either residue from the gasket or it has been leaking through there. These two are going to stay together as a unit through the cleaning processes, and they will go back together on the plane as a unit. Same amount of wear or carbon build up in the head. You don't see any signs of leakage around here. That shows it was installed properly. Before we can remove the pistons and wrist pins, we're going to need to pull the gearbox off and the fan tower off. It will not separate unless we remove these two nuts. Okay. That's the rear seal right behind this gear. So if it does leak, it leaks into the gearbox. There is an O-ring here that seals this off, and there's an O-ring behind this adapter that seals it back there. Gearbox adapter off now. It simply comes off with these 4 bolts, which bolt up to these 4. This is a Provision 4 engine. The newer engines now are Provision 8. They don't require an adapter. They have 2 extra bolts that are internal in the gearbox. You do have to separate that gearbox to remove it because there's 2 bolts inside you have to remove. Okay, I'm going to rotate the engine around here a little so you can see what we're doing. At this stage, we're going to remove the gear drive. And you do that by inserting the pin in this particular engine. And there is an offset. You want to be careful when you bring your pistons down. There, it just fit in. And that locks that up. If your pulse port is on the mag end of the engine, as it is on a 582, you must remove this before you remove the cylinders, because the way you do it is with the head still on it. You feed you get the piston halfway up, you feed this down through the head, and then you crank it up until this stops the crankshaft from turning. You fill it with rope, in other words. Very similar to what we used to do to change valves on a car engine. If you didn't have the air connector that would hold the valve in place, if you were just replacing the keepers or whatever, I mean the seals, valve guide seals, this was a method that was used. On a 503, the pin's right back here, but remember, on a 582, you must have a rope and pull that gear before you remove the cylinder and head. So all I'm using is a breaker bar here. It's got about 40-something pounds of pressure on it, and for this purpose, we're going to lay it over gently. There we go. And again, notice even back here, we've got this European lock washer, and you can tell right now which way it's angled. It's going towards the bolt. Even though both of these surfaces are steel, you just get in the habit of turning them both towards the bolt. In this particular application, you could turn them either way without hurting the function or the part. Now, when you pull this off, it's usually full of gear oil, which it is. We can take a little rag and just kind of wipe this down. We want to let that drip. Okay, earlier on, you remember we talked about the A and B drive gear puller. This is it. How this works, this threads into the threads that are inside of here. Okay. Once it is attached, we start screwing this in. It goes in through the bolt we just removed, okay, and bottoms out on the back of the hole, the bolt hole. So I'm reversing it. We simply insert it, make sure it starts in the hole. We screw it on here tight all the way down. Again, the pin's still in here, so it's fixated to crankshaft. And when this breaks loose, it could just pop out clear into the floor. Okay, we just popped it loose, but it did jump off. And that is simply how it comes off. It is recommended that, again, you use the rope method. We've already removed the cylinders. So for just these light duty bolts, I'm going to use the pin. And by light duty bolts, I'm talking about these three. We would never try to take this nut off by using the back thing here. The crankshaft is pushed together, and if you were to try to take that nut off with the pin holding it back here, it would twist your crank and ruin it. Again, I'm not using the impact or the air ratchet because I don't want to transmit any vibrations through here. And these are not on that tight as you see anyway. Once we get those three bolts out of there, the pulley will come off relatively easy. Now, it shouldn't have come off that easy because, again, this one is way too loose. I shouldn't be able to get that on there without inserting a bolt and rotating the engine around. It is so loose that this has been rubbing on the wall there, and that's probably a worn out belt. It's definitely too loose. And simply take those parts off, keep them together, move them out of the way, and at this stage you can pull the belts out like that and rotate them out of the way and go into your flywheel. Okay, I want to cover with you how to adjust these belts, so we're going to go ahead and pause here while we remove this bolt. We are going to use our fan tool, which simply fits in like so, and then we're going to use a bolt with a breaker bar or a ratchet, and this fixates the fan by these three prongs in here, and you will not break off a fan blade. That is both edges are turned in one direction. If you were to put that on there backwards, and this being nylon, can you imagine how fast that would eat into that nylon? So it always should be turned to the back of the nut. Or, yeah, in this case, a nut. After you pull that off, this simply comes off, and there is your pulley. Okay, we've removed the fan, and if you notice, right here are the spacers that go in between the two fan halves. Here's the back half. This is the front pulley half on here. Okay, they fit together with the bow out. They fit together, and by adding or removing shims, you make the distance between the pulley halves more or less. Okay, and at the same time, every time you remove this, you should take some emery cloth, a wire brush, something, and you should get all this rust off of here. This rust is going to wear on the side of your belt, which it has, and abnormally wear it. While we're here, we're going to go ahead and pull the shims off quickly. This one has 3 on it. There should be probably more than that in a new one. Pull this off, and that is the washer, so it is missing shims. Some people mistakenly store the shims behind the back pulley. They should not be stored back there. And this is what I mean by the pulley halves. And this is what I mean by if you put shims in between it, it will make it stand apart, which allows the belt to sink further in there and loosen it up. Okay. Again, all of this rust should be taken off. You don't want to use a grinding wheel. just want to use emery cloth and take the surface rust off. You don't want to grind into it because you'll take too much metal away. And they finally reach a point where the pitting gets so severe that you'll have to just replace them. This one's nearly to that point. I won't know till I emery them up. But another thing you want to check here, well, while it was off, is you want to spin it and listen to the bearings. Can you hear that? Those bearings need to be replaced. The fan turns twice as fast as the engine. So if you're running along at 6,000 RPM, this fan's spinning 12,000. You should always use the flywheel puller when pulling the fan, or pulling the flywheel. Number one is, if you look, there's very few places that you can get a 3-jaw puller in here to pull it out. If you try to pull it in here, you're more likely to distort or break the flywheel. And it is in 2 pieces. There is this front part with, you can see screws that are coming through from the back side here. There's 4 of them, I believe. And we want to put this lug over on this heavy material where it will push against it and probably will not be able to break that big piece of casting out. And then you just rotate the flywheel till it lines up. Once we get this in here, you notice that will stop that acts as a freezer. We simply put a 30 millimeter on that nut, hold the engine down, and that came loose kind of easy. It certainly didn't have 60-something foot-pounds on it. That's the nut that goes on there. Again, there's another washer underneath. Easiest way to get those out. Flare goes to the nut or bolt, bottom of the bolt head. Simply presses on there and will pull your flywheel off. You want to screw this all the way in, back that out. Okay. Now, when this actually breaks off, hear it pop, it's off. All you do then is simply pull it off, and there's what the inside of your flywheel looks like. What we're doing here is we're simply removing the fan tower. This is called the fan tower. It's held on by those 4 bolts. And all we want to do is remove it, because we can't split the crankcase while this is holding it together. All you have to do is you go in this side with a slot. Let me do it on this end. It will make it much easier to see. Okay. Simply put it behind the clip. See how the ends are right there. They're going to start closing up because it's pushing them together. You put your finger over it to make sure that circlip don't go flying out into your eye. There it goes. Once you have it is not a reusable item. This one looks like nothing's wrong with it. Okay, this one looks okay. Guess what? It's going in the garbage. You do not reuse circlips simply because they may be bent and you don't know it. Okay. If you ever do a decarb on an engine, you want to pull the pistons off. Don't let anybody convince you that you can put cardboard over the top here and do a good job of decarboning your engine. You can get the carbon off the top of the piston. You can get it out from behind the ring grooves after you remove the rings. But how are you going to get up underneath the piston where you're going to see carbon does build up? Yep, these are cageless bearings. These have the old type wrist pin bearings in them, which would have tore up that other puller, so we're just using a standard puller. This is the side that I pulled the circlip out of, because if I hadn't removed the circlip, of course this wouldn't be coming out. Or if it was, we got a more serious problem on our hands. This one doesn't have much carbon below here, but where you see the blackness will build up with carbon. With that sitting on your engine like this and your plugs upright and your pistons upright, where if that carbon, if this were carboned up and it were to break loose, where is it going to go? It's going to fall straight down into your crankcase. Carbon is hard to the point that the only thing harder is diamonds, and it's made from carbon. This is our mag piston. We haven't marked the mag stuff, so we don't, or no, that's the PTO, I'm sorry. This is the PTO end of the engine. So all I'm going to do is etch in this flat surface the letter P. That way it will stay matched to our PTO cylinder. What we want to look at here is rust and wear and heat on the wrist pin. You can take your thumbnail and usually feel across there to see if there are any ledges. There's a tiny bit of a ledge right there. This is a cageless bearing. We use, this is a cage bearing. Rotax now recommends cage-less bearings. The reason is, with cage-less bearings, you have twice as many needles in there. This has quite a bit of space in between each of these needles. Okay. With cage-less bearings, you've got a needle between each one of these, so you've got quite a bit more bearing surface. And there is no cage. They just fit in there loosely. Here's an example of the cageless bearings. There's twice as many bearings in there. Yeah, and then this is just how they come, so they don't just all fall If you can't count to 31, you have no business touching cageless bearings. That means there's 31 cageless bearings in here. If you only put 30 back in, you've got a problem. But again, that's what the cageless bearings look like. I just wired these together so that when I show them to people, they don't just pull them apart and the needles go everywhere. Okay, we've removed all of the bolts from the crankcase assembly, so it should be ready just to simply split apart. Now, we open these with just a flat tip screwdriver. The thing is, those two surfaces are machined smooth to fit together, and it uses a gasket eliminator compound that that seals between those flanges. Okay, this is supposed to flex as the engine heats up to not cause it to start leaking in those cracks as the engine warms up and cools down. You want to be very careful that you don't get your screwdriver all the way into the mated surfaces. For example, right here, you can push the screwdriver in pretty far, okay, because that's recessed in there. Right here, for example, you can see the mated surface just barely inside there. So you don't want to pry here with the screwdriver hardly at all. Back here you have room to depress your screwdriver, and that's what we're going to do. But we want to start here at the center and do it kind of symmetrically. And you don't put a lot of pressure, you just do a real gentle pry. Now, as it opens up, you can accidentally put your screwdriver between the two mated surfaces. You want to be careful that you don't do that. Okay. At this stage, you can see what I was talking about as far as the mated surfaces versus these areas that I could put the screwdriver into. You never want to pry on the mated surfaces, okay? Because if you put a gouge in there, it's just a place for it to leak. Same with the top. What we want to do here is use a rubber hammer, simply lift up on the crank and barely tap on the casting. There we go. Once you get her broke loose, it'll come right on out. The next thing we want to do a quick inspection on is how much have the bearings spun in their castings. When you can't buy half a crankcase, these crankcases are serial numbered, and there's an etching on them, or at least on the new ones, where they actually put a number on the top and bottom half with a vibrating etching tool. That is because after they cut this and surface it, they bolt it back together again and they line bore these holes. Okay, and once they get out of line, the casting is no good. And the primary reason that they get out of line is bearing spinach. What's happened here, these bearings have spun to the point that this needs to be bolted back together and mic'd I can feel the lip right there with my thumbnail. Okay, all these bearings have spun, and when they eat into the aluminum, they're no longer truly lined. And the same way with the other half of the crank. You know, there should be reciprocal marks on this half, which there are. The bearings have spun quite a bit. Again, I can feel that with my nail. It looks like this bearing is actually seized and let go and seized and let go. These rubber plugs, their purpose in there is to press on the bearing and try to help it resist from spinning. They're replaceable. They're simply a rubber plug that presses against the bearing on the crankshaft and tries to keep it from spinning. Okay, that's their whole purpose in life. And if you hear people talk about bearings spinning, that's what they're talking about. Is marks will show up in the crankcase. Once they have exceeded their wear limit, this crankcase is no longer any good. Okay. We got to bolt it back together, clean it up, bolt it back together, and use a dial bore gauge inside each one to measure them. If it wears out, then the bearings are just going to spin more freely and more freely and more freely until, you know, everything will fall out. There are overlaps in the different jetting phases. You have an idle circuit, which controls it from an idle up through about 1/3 of a throttle. The only adjustment for that idle mixture, it is a jet down in here. It has different size holes in it depending on the jets that are in it. The only thing you can do to adjust it, and this is called an air bleed screw, is you can screw this in or out and adjust the air, because the piston is going to be down at the bottom. There's going to be very little air coming in through the piston. That little square part that's out of it. When at an idle, that's all the air that's coming through it. Okay? But if you notice this little hole right in front of there, that's where your mixture comes in. See that tiny little hole? That's where your mixture comes in for your idle. And that little square hole back there will lean it out just a little bit. Okay? In order to adjust this, you screw it in to give it less air, and you screw it out, in being clockwise, out being counterclockwise, to let more air in with the mixture. You can get it too lean or too rich, and the normal signs of that is rough running. It will normally run rough. Normally, for most applications, this screw, you screw it in till you feel it bottom out. Not tight, you don't want to torque it down because it's just a needle going into a hole. You want to just move it in till you feel it stop, and then back it out a half a turn for most applications. That's where you start. Okay? And that is basically the idle circuit. The air goes in here, in this hole here we're looking at, and goes along this passageway, past the screw, along through a passageway through the carburetor, straight in line with this, and comes out here mixed. And you notice the needle is right behind here, and that's where it's mixing it at. Okay. Next thing we're going to do is we're going to pull the float bowl off. Well, we'll take the cover off, because it stands upside down a lot better. We're going to examine it for wear as we tear it down. It's inspection time. You notice that the cup is on top of the needle clip. That is the correct way. The spring then sits inside that cup and holds that needle in place. Holds that needle down. Okay? If you install this backwards, and it can go in that way. Let's say you accidentally put the clip inside of the cup. It will fit. It's incorrect. What this effectively does is raises the height of that needle from down here to up here, which is completely changing where it's setting as far as your screw. These are your adjustment points, is these little circle. That's where the clips go in, and there's usually it will go in the middle. In this case there's 3 of them. The new ones have 4, and most of the time it starts with the second one from the top. When they talk about the needle clip, the smallest number always starts at the top. So this is position 1 at the very top. Position 2 is in the middle. Position 3 is at the bottom. When you move the clip down, it raises the needle up because it holds it at a different level. And again, you want it underneath there, not on top of there. By the way, this is an old style clip. It will certainly be replaced. This one is definitely worn out because it should not spin on the needle. It should grip it with enough friction that the needle doesn't spin. Because here's what happens. You've got that in there. Okay, we're going to hold it down here. And this needle can spin. See how easy that's turning? The needle can spin, and it spins fairly easy. When that is raised up in flight, that needle's just sitting there spinning around and around and around and around. It's steel, probably stainless steel, and it goes into a brass jet. It's called a needle jet. This is called a jet needle. But the needle jet is made out of brass, and it's tapered inside to correspond with the taper on the pin. As it spins inside that brass, what is going to wear? Stainless steel or brass? The brass is what's going to wear. So you don't want this spinning. If you have one that's spinning, number one, when it starts spinning, the diameter in there is actually getting eaten away by the metal here. There have been cases of people flying along, and wherever they've got that notched, that it actually breaks off, and then the needle just drops to the bottom, effectively putting that carburetor, if it's a dual carb application, at an idle. Okay, these engines, even though they're 2-cylinder engines with 2 carburetors, they are 2 separate engines that are attached. If you put one engine at an idle and try to rev up the other one, it won't do it. You might get 3,000, you might be able to coke 3,000, 3,500 RPM out of this engine, The best thing to do is, if this ever happens to you, is land the airplane. Okay, if you don't have throttle control, you land the first available place you can find. There are updates now. What they have done to try to eliminate this problem is, number one, they've changed the shape of the new clips. It has more meat, more metal in this area right in here. Okay, which helps it hold it tighter. Along with that, they've come out with a new cup that right in, let me use the needle for a pointer, right in this area, which is where the needle sits, it's cut out and recessed just a little bit. But you can't just take a drill bit and do this one. It'll get in there and crack it, and it's no good. But it has a recess made right in here for an O-ring, for a rubber O-ring to sit up in there. And what you do is, okay, we replace the clip with the new one. You hardly ever use the top setting. The reason it's there is just to allow you to move it one more space. Okay, almost all of these call for an initial setting in the second hole, a second slot. You would put that O-ring, and it's a very small O-ring, right in that first groove. Okay, and when it's compressed underneath here, is going to make that needle resist spinning. Okay, you can really tell if your needle has been spinning by looking up in this area. I'm going to pull the clip off of it. Is looking up between the bottom hole and right above that ledge there. There are numbers on this that tells you what size needle it is. You're not going to be able to see them under the video camera, but and this one is not a real good example because this is not all bright and flashy, but you can see right there where my thumbnail is, where it's shinier above it than it is below it. And you can see right there at my thumbnail also where it has been spinning and started to wear. We're going to look into the bottom of the carburetor now. This is where the majority of your jetting is inside the float bowl here. Now, again, as we're tearing it down, we want to analyze different potential problems that we see. There is a lot of oil in this area. It's green, so I assume it's Pennzoil, which is popular around here. Let me turn it into the light there, and you might be able to get a better shot of it. But there's quite a bit of oil. That's oil residue right up in here, if you can see it. You can see it's a real shiny. That's oil. So, in my opinion, the needle that is supposed to cut off the fuel supply is probably worn to the point that if it's a gravity flow system, that fuel would continue to fill the bowl and come out and drain into the air cleaner. That may be why that air cleaner had darker spots on it. Was maybe the oil, maybe that was the bottom, and this oil had oiled that portion, but not the rest of the air cleaner. Okay, at this point, we know we had gas in here yesterday, so we're going to be very careful, because again, I believe, this is getting off of ultralights, but I believe that we need to protect this world for our future generations. And so we should try to comply as best we can with the existing OSHA regulations and not pour oil and gasoline and kerosene and those type of products into the ground. We've almost ruined all the American wells now in this part of the country anyway. Took the bail off, just simply lifted the carburetor off, and we're only going to flip it over and set it there. Okay. This is about what was in it yesterday. I'm going to drain it into my quote-unquote sump can. This is where carburetor cleaner, any kind of solvent type materials go. And dispose of them properly. Then we're going to simply take the floats out, set them over here, and we're going to examine the inside of the float bowl. Okay. The inside of this float bowl, as you can see, is absolutely filthy. Somebody has taken a screwdriver, and has tried to scrape the dirt off, but they've only halfway done it. This is why, as an authorized repair station, I have a bead blaster. Once that gas dissolves out of here, this would be bead blasted, so all of that crud is gone. Then it would be washed. Internally and externally, we're going to bead blast it because we want it to look as good as we can. Okay, and we want it to be as clean as we can. We're going to bead blast it, we're going to wash it, we're going to rinse it, and we're going to let it dry. Or dry it by hand. Okay. And the next thing we're going to look at is the jetting, which is inside the float bowl area here, the bottom of the carburetor. But before we do that, let's talk about a subject that I always get questions about, either through the people coming through my doors or the talks that I give. And that question is usually something like, what's the rubber tube for? Okay, the rubber tube is there simply to let air enter your float bowl chamber while the fuel is draining out through the jet, so it doesn't create a vacuum in there. Because there is a gasket up here that makes a relatively good seal. It's a cork gasket. We're going to remove it later. You will see it. And that pretty well seals that bowl up. That's why you can tilt this and fuel doesn't flow out of the top of the bowl, because it does have that gasket around there. So it makes it airtight. So it needs a place to let air come into the carburetor as the fuel goes out. Now hopefully you've got fuel replacing the fuel that's going out. But just on the off chance that, say, this were to get plugged up or momentarily stopped, it would create a vacuum in here which would effectively stop your engine. What these tubes are for is to create a static port, meaning it doesn't pressurize this bowl area, and it doesn't create negative pressure in that bowl area, or a vacuum, for lack of a better word. And it does it by putting a static hole down here at the center that is basically out of your airflow. Okay, this carburetor is going to mount like this, and you're the airflow. Okay, if this hose was not on here, it would ram air into that vent line, which would effectively pressurize or put positive pressure in our float bowl. Okay, in an effort not to do that, they put another port on the opposite side that the other end of the hose goes to. And if this were to get stopped up, the one going into the air, this would effectively, by being on the downwind side, would draw static air, or would draw and actually create a vacuum inside here, which wouldn't allow the fuel to go through the jets properly. And that in a nutshell is what that hose is all about.
Can you show me the holes where they come out in the...
Oh, sure. This is a very simplified, you know, if you want to understand truly how this works, it's very simple to understand. If you notice, the brass end goes into an aluminum casting, and that casting runs down into the top of the float bowl. It does it on both sides. Well, this one you can't see, but right there is another casting that's going down. Right in here, the light's just not quite right to see it real well. But if you follow, let's go to the other side because it's more plain. If you follow that, look inside your carburetor, there's where it comes out. There's the hole. And it's on both sides. There it is over on this side. And it just simply lets air come in to replace the gas as it goes out. If it's needed. If it's not needed, it doesn't do anything. You know, if the exact amount of fuel were to enter here that goes up the jet at all times, it wouldn't need that port. But because those vary with throttle positions, you have to have a static port to let the air get into your fuel bowl. Next thing we're going to do is we're going to talk about the idle circuit. If you notice, there are 3 main jet ports in this carburetor. This front port and by the rear port, excuse me, I can tell because the knurled end goes towards the engine. Okay, this is where the carburetor boot fits. This is where the air cleaner fits. It's a smoother surface. The newer ones have grooves cut into it to give it more friction so the air filters don't come off as easy, but it's still a larger entrance, etc. Inside this rearmost port, and I'm going to try to angle it down there if you can see that, is your idle jet. That idle jet is numbered. I doubt we'll be able to see the number, but and it's preset. It has holes drilled in it that allow a certain amount of fuel to travel through it and no more. And that's why the only adjustment that you have is there, and you can adjust the amount of air that is mixed with that fuel. Okay, we're going to remove it now. You want to use a good straight flat tip screwdriver. You don't want one that's going to slip greatly on a screw. You know, will burr out the screw threads, or not the threads, the head, because this is a brass jet that's in there. So you want to use a good quality screwdriver. It must fit down in there loose. And all that is bottomed out. It's not, you know, jammed in there with tons of torque. You put it in, you snug it, and you give it just a little tweak, and that's tight. Okay? To remove it, show how little, and it broke free. But it needs that little so it doesn't just fall out into the bowl in flight, because then it would never idle properly. Falls into our hand. The number tells you the size of the jet. It relates to, first of all, there's a hole in there, in the thread, in the screw head area, that goes straight in to the jet. That's how the gasoline, when it's in the jet, down in the fuel, that's how the gasoline gets into the idle circuit. It's through that hole. It comes up here, and there are a multitude of holes. And that's where it gets mixed with the air from the air bleed screw. Right there. Okay? And it also is allowed to come straight out the bottom. Or the top, as it were. Because this is the way it would be in your carburetor. You want to clean these. And the best thing I've found to clean carburetors, the aluminum blocks, etc., is simply a generic carburetor cleaner. You can get your favorite brand. The best carb cleaner and the cheapest carb cleaner is going to do about the same job. You just want to make sure it's carburetor cleaner. If you're using this to clean on the engine or the external parts of the engine, and I'm going to use it here just to show you how effective it is, we've got a little spot. I'm looking for some oil or grease. Okay, good example is the front part there that is oily. Okay, let's try to get a good shot of that. You can see a green cast to it. Watch what this does. It's gone. It's bright and shiny. You can use this anywhere on your engine except for the painted portions on the air-cooled engines, like your shrouds. You don't want to use carburetor cleaner on shrouds because it will eat the paint off. You don't want to use it near your neoprene or your rubber seals, as in your crankshaft seals. You don't want to use it between the blocks of the engines where we put the gasket eliminator, because it will soften that up and potentially cause an intake leak. To clean the jet, I simply grab my carburetor cleaner. It's not going to harm brass. I fit it into the end of that jet, and this almost fits perfectly. I want to put my safety glasses on so that it doesn't splash me in the eyes. I'm going to hold it over my garbage can, and I'm just going to spray into it. Fuel should come out the end and out those holes that you saw. Let's see it come out the end now. A little spurt. And after you've cleaned it with carburetor cleaner, you just use compressed air. Put it up to the butt end there and simply blow. Did you catch that spurt coming out? Okay, on the air bleed screw, again, the small screw out the side, not the large screw. This is your idle setting screw. This is simply, if you can get a shot, and let me try to turn it to where the light's going to be to your advantage. If you see, let me turn it. Down at the bottom, you're going to see a triangular or pointy shaped object right there. That is the other end of this screw. When you screw it in, it goes in further and it stops the piston from going as low. It in effect raises the piston. Okay, so you screw that in, it's going to raise the piston and allow more fuel and more air to go through the carburetor part. And if you get it too high, the idle has no effect. For the next jetting point, we have our main jet, which is right here on the tip. Right here on the tip. You hold it with the 10 and you remove it with the 8. And it just simply screws out. And it has numbers on it which tell you the size of the jet. You may be able to pick those up. They are relatively large. That you can see is a 165 main jet. Okay, somebody has removed it before and just put a little nick in the side there. That doesn't hurt it as long as the hole is not damaged. Below that, or again, this carburetor is upside down, so above that, And the only reason that the jet fits in the end of that as opposed to screwing in up there is because that sits at the bottom of this hole, of the bottom of the float bowl hole, this recessed part. When you put that together, as you can see, your jet is going to be right down in there. Well, my thumb's in the way. The jet is going to be right down in here on the inside. Okay? And that's the main reason that this is the length that it is to hold that jet down there. That way, even if you're into a bank turn where the water or where the fuel sloshes to one side or the other, the main hole down there is still submerged. If the jet looks varnished, as we discussed, or it's looks marred, the holes looks like somebody took an awl or a screwdriver and tried to clean it out, replace it. It's never going to be right. Replace it. And by the way, Bing recommends that you replace all jetting every 2 years. Okay. This next portion again is not a jet, it is simply a standoff. Below that though is our needle jet. The jet that accompanies the needle. We simply screw that out. And again, you can sometimes see varnish building up, what I'm calling varnish. And most people will recognize that term from fooling with old 2-cycle weed eaters and stuff like that. Or old lawnmowers. Old lawnmowers that's had, even 4-stroke lawnmowers that's had gas in them for a long, long period of time. Get a shot of this. There's water in there. See these bubbles? If you can make them out. Okay. There was water in there. Okay. Somehow water got trapped, and it was probably, remember us discussing the throttle cable boot? It probably came down the throttle cable boot and just rested there. Came to rest in that point. Where's my standoff? This, again, all the jets have a number on it. If you can see that, that one again should come in, is a 2.70. Okay? This works in conjunction with the needle. Okay? The needle works up and down through there with, again, this being below it and the main jet. I'm moving around a lot on you, just bear with me. The main jet down here. Okay. After you've reached 1/3 of a throttle, you are running on the needle jet. It actually lifts out of there and it's tapered, as you can see, and the jet hole is at a certain diameter. Okay, it's a precise diameter. And again, if this needle is spinning around in that brass jet, it will change that diameter. So, once you come up off of an idle, the needle starts, after about 1/3 of throttle, this will start retracting out of that jet. Okay, and what happens is at that point, the dimension between the needle and the interior of the jet is controlling how much fuel is coming through there. So as you add throttle, the needle gets smaller and lets more fuel through. As you drop, as you pull the throttle back, it's recessed down in here to the point that it actually cuts it off, and then you're running on the idle circuit. So that's how these work. And when you're going at 2/3 throttle to wide open, this pulls out to the point that the hole in here is larger than your main jet. Then you're running, if you were to leave the needle out, you would have an idle circuit and you would have a wide open circuit. You would have no mid-range. Okay. It's important, especially if you have one with loose clip that's been spinning, that these get replaced fairly often. They're not that expensive of jets. The needle is approximately $7. The jet is I believe it's $7.29 through me. Okay, and once we remove those, if you notice in the idle hole here, oh, let me move my fingers and maybe you can see the light behind it. There is a hole going straight up into the throat. Yeah, there you caught just a glimpse of it when I moved my finger. There was a tiny, there, just caught a flash of it. There it is. There it is. This other one is simply open up through that brass hole right there. In there. Excuse me. Again, let me move my hand. There you can see that brass insert that's in there. The next important part is our needle valve and seat. The seats will hardly ever wear out. Different applications have used different techniques to do the needle valve and seat. Some old four-stroke lawnmower engines used to use a rubber seat with a metal needle valve.
They call it float valve or needle valve?
Needle valve. And I need my pliers here to finish pulling this pin out. Just gently, you don't want to bend anything. This pin, just as an explanation to you, is the perfect tool to use in the dual carb fuel pump rebuild kits. There is a rubber plug that you have to push through a hole, and it has a hole in it. You can put that pin in the hole, push through it, and it works perfectly. We're not going to cover that today, but I thought I would throw that in. I'm going to place it out of the way, and this is our throttle cable arm along with this little clip that just came loose. It's just a tiny piece of wire that holds the needle valve to the clip. Can you see it on the end of my finger there? And there is our needle valve. And as I predicted, if you will look at that, this needle valve is wore out. It should be a straight taper. Should be a straight taper all the way to the tip. If you will see, this has a ring around it right there, which means it's wore out. It's not a straight taper, it has a lip. That's going to cause it to leak. Okay, this comes in a rebuild kit along with the little clip that's attached to it, along with the gasket that you need, a new gasket that for the float bowl, along with, once you remove this screw, there's an O-ring that goes, remember it's an air bleed screw, so it has to have a way to seal from the outside air so that air doesn't get sucked through the threads. So we're going to remove this. Again, it was 1 3/4 when we started. I want to remember that. And again, it is just a brass point with a O-ring around it here. That O-ring around it here simply seals it off from the outside air. Okay, and if you notice, This doesn't even look like an O-ring anymore. It looks like a rubber band. It's flattened out. See, it's almost flat this way. So it's in dire need of replacing. We definitely need to kit this carburetor, and by kitting it, this is what I'm talking about. This is a Bing 54 rebuild kit. In it, it includes the gasket. It includes the O-ring, the large O-ring that we didn't talk about, but it fits right around here. It wears out too and allows air to come down around the piston. Okay, so you replace that. It gives you that new pin. It gives you a new needle valve. It gives you a throttle cable boot, and it gives you the little screen that goes down sits right on that lip in there, and goes up to the threads here. I didn't see a screen when we took it apart.
No.
So I'm going to assume the screen was missing. Can you get a good shot of that screen there? Okay. It has a nylon, or this one appears to be metal, but I believe it's a nylon, tiny, tiny filter material. And most people, when they look at that and realize, okay, that's right down around that bottom hole in the carburetor, they think it's a final filter. That is not a filter at all. It is a fuel stabilizer. If you, with this carburetor, were to suddenly, through intention or non-intention, go vertical or even inverted, your jet's going to be sticking up in the air and the fuel's going to go down, okay, based on gravity. In this case, the fuel's going to drop to this half of the carburetor and you're going to have air up here, okay. All this screen does is slows the drainage of the fuel from out of that recess. It slows the drainage of the fuel out of that recess when you go horizontal or inverted. That way your main jet will have a few seconds of fuel before it starts sucking air. It's a little bit of a fail-safe. It's a little bit of a fail-safe. It's not a final filter. It is a fuel stabilization screen. It's also designed, as the fuel flows through it, to take out air bubbles. Just like the Mr. Funnels. It won't let air or water through there, so water's not going to readily appear down there. But its primary purpose is to slow the flow of fuel from the main jet. And this one definitely needs a kit. I want to show you how to set your float level. These arms here ride on this pin. Let me turn it sideways and you might be able to see it. Like so. Level of the fuel in the bowl determines how low, high or low this rests. And what the arm here does, we've reassembled this for this effect, is that is your needle valve and seat. This is your arm, and all it does is raise that needle valve up to allow fuel to come in, or when the fuel bowl becomes full, it pushes it up, again this is inverted, to stop the inlet of fuel into your carburetor. Okay, so it doesn't overflow and flood out your engine. The way you adjust this is you can do it with a ruler, a fine ruler, or you can just do it by eyeball. You want to look at this flat surface right here, and it must be parallel with the top surface here. If it's not parallel, you need to bend it down or up a little till it is parallel. And the way you adjust that is you don't grab the arm right here with a pair of pliers and bend it. You don't want to touch the arm because you're just going to ruin this whole piece. Okay? The way you adjust it is the tab that sits right on top of the needle valve. There's a little tab there in the middle. See it right there? Okay. This one, just for example, is relatively straight. It is relatively parallel. But to adjust it, you simply bend this tab up or you push it down, depending on which way you need to go. Now I'm going to move it so that you can see what one out of adjustment badly looks like. Didn't go enough. There's one pretty badly out of adjustment. See how they're not parallel anymore? This arm slopes down. You still may not be able to make it out, but it's definitely not parallel with that seat, with this edge. Okay? In that case, you would bend it backwards, which means we need to just push it down a little bit. But you don't want to push down on the needle. That can ruin that needle. That may be what happened here. You raise the arm up, you push down on it, and bend that tab back down just slightly, and you check it. One other thing I would like to talk about just briefly is the choke assembly. Or it's not actually a choke on these carburetors. It is a fuel enrichment circuit. These carbs have no choke. A choke is actually a butterfly valve that closes off and closes off air. This actually enriches the fuel because when you depress this lever, it lifts up a seal that's right down in here off the top of this tube and allows fuel to go directly up the tube and into the carburetor through this hole. Let me try to get you a light. Okay, and there's the hole. There you go. Yeah. And allows fuel to come in there. Chokes are rarely used anymore because most of the newer carburetors are equipped for primers. And I say equipped for, not with. This carburetor is a 1987 carburetor. We know that from the age of the engine. Along with that, we know it because it has no pulse or no primer port. There's actually a port made into the carburetor for your primer hose to attach to. And I have a newer style carburetor right here. It's identical to the other one, except it has that port in it. If you rotate it around, you can see it simply goes into the carburetor and has a tiny hole in it, which is a jet. Let me use the flashlight here, because I really want you to see this. It has a hole in it. A tiny little hole. When you spray gas in, it sends a mist out there and is much more effective than a choke, works faster. Along with that, if you're not using that the primer outlet here, you know, if you don't have a fuel line attached to it with a primer plunger, it comes with a rubber cap over it. These rubber caps, just like the carburetor boot, is made of rubber, and it will crack and split, and if you let it suck air, you're changing your air-fuel mixture, and you're in for overheating EGT problems, if not engine seizure problems. Okay, this is your float bowl with the floats installed. Okay, the floats simply float up and down on these pins. You can see the pin protruding out of it. The pins that go to towards the middle are what activate, or what this arm activates, or what activates this arm, would probably be a better way of saying it. And by their constant movement, they do, I don't know if you can get a close-up of this, get wear on the side of the pin that has been rubbing on the arm. If you see much wear, you can see a shiny spot there. You see there's kind of a shiny spot right there. When you see wear start to show up on that pin, simply rotate the float over and you've got a fresh surface. When an engine, a Rotax engine, stops, it almost always stops with one piston at top dead center, which means the other piston is going to be at bottom dead center. Okay, the piston that stops at the top is open on the intake side to the crankcase. The piston that stops at the bottom is open from the exhaust side into the cylinder and head area. If you don't do something, winter condensation or just damp weather condensation can get through your engine and leave deposits of water. Deposits of water will end up in your crankcase, and once it rusts all that metal stuff in there. Another thing, again, that I'm a stickler about is these carb boots, because again, if there were a slight drippage or some condensation, it would certainly run down here, go inside the carb, end up in there. When you start the engine, you're sucking water into the engine. If it gets so much water in there that it overflows, it will actually flow into your engine. And just because the piston may be partially covering that intake port doesn't mean that water can't go between the piston and cylinder wall. And then it ends up in your crankcase, and then it rusts the bearings, and then you're in for a rude surprise. What we've got here is a motor that I keep around to show people the kind of things that the catastrophic things that you can run into. This crankshaft is one that I replaced during a 300-hour rebuild, and the reason that we replaced it, besides the age of the crank, which is well over 5 years, was the fact he had stored this in a hanger on a table. Okay, and he had not plugged any of the intakes or exhausts. The manifolds were off of it, the carburetor was off of it, and like I said, when you stop this engine, it almost always stops with one or the other piston at top dead center. This would represent top dead center. If the cylinder were on there, you could see in the intake port into the crankcase. Now, whether this water came from rubber coming down his throttle cables, because we did find water in the carburetor, or whether it was because of condensation, we don't know. But what I want to show you here is the severity of the problem. I'm going to pull the front seal off there. The rust inside the bearing is as bad as you see right here. Okay, this bearing is replaceable. This web is not. This is called a web. This web is not replaceable. If you've got rust there, and I'm going to rotate this around, and if you can see it, we've also got rust right here. That's all rust. What are the odds that that rust hasn't migrated down there and has rusted that pin that goes through here? Okay, or the cage needle bearings that are in that crankshaft, the lower end. I'm going to lay it down there just so you get an idea of what I'm talking about. You can see this is the only opening to allow you to see the lower cage bearings. Okay, and I'll rotate to the other cylinder just because you can get a little bit better view. In fact, under close-up with a camera, I'm seeing some rust right along here. Okay, you can only inspect about less than a quarter of the length of these pins because they go across like so. So this is why when you find rust on the crank, you just replace the crank. There is no sense of replacing the front bearing, putting the engine back together, and running it, because if there is rust in there, it's going to fail relatively quickly. And once it fails, all these bearings, which are little pins, just become shrapnel. And they go all through the engine, through the crankcase down here, through the piston ports and the cylinders, to the top of the head, and it's just going to literally destroy the engine from the inside out. This is why schedule maintenance is so important. In my experience, I'll be honest with you, this is the first one that I've run into that had serious rust on it. But this one was so severe, I definitely kept it around so I could show people. For winterizing, you know, for putting it away for a period of time, my advice to you with an application like this is simply get a big baggie, a big Ziploc bag, get two that will fit. One will fit on each air cleaner. Okay, put it over, Ziploc it up as tight as you can. Put a little bit of plastic tape around it, whatever, so air, that wet air doesn't get into your carburetors and into the engine. At the same token, and you can use multiple items here, you need to plug off your exhaust. This is just a conduit for damp air going into your engine. You can get a rubber plug that at a university, what do you call it, laboratory supply store. You know, they have rubber plugs that fit for the beakers and all that kind of stuff. You can simply take a heavy-duty baggie, a freezer bag, wrap it around there and put a wire tie on it. You know, just something to keep the flow of air through there, so that the engine doesn't breathe on you in the winter, because you don't want to get that condensation inside. You do not want to store your gas in the hangar for any more than probably about a month. At the same time, if you premix your gasoline, you do not want to store it in the bowls. So whether it is a 2-week that you're going to be down, or it's all winter that you're going to be down, you should always pull the bales and drain your bowls. Drain the gasoline out of the bowl. And I don't mean sling it out on the grass. I mean put it in a receptacle, but they should be drained. The reason being, and I'm going to pull this one off to show you, is you see this sump down here. Your main jet sits down in that sump, okay, which you'll see when I take this off. See where that's your main jet right there. And it's sitting down in the bottom of this sump. Okay. And if this fuel is mixed with oil, it can start to turn to varnish. If it varnishes that main jet, it in effect makes the diameter of the hole in it smaller. So that the longer you leave that jet in poor fuel or mixed fuel, the more likely it is to become a smaller jet. And there's no way to really accurately measure it except put a new one in there and see what your temperatures do. And what we're going to do next is go through how to connect up your carburetor. We've already loosened the screws here. This part seems to confuse the most people as far as how to disconnect and bring it to your service center. When I'm first disassembling a plane, I do not touch any of the settings. This is locked from prior use. I'm not going to modify it. I'm not going to move it. It's still locked. To remove this cable assembly is not a hard job, but it takes 3 hands. And I've only got 2, so again, with a little experience, what I'm doing here is there's a plastic cup inside. All I'm doing is using the needle to push the cup up to get the cup outside here, and then just rest it on the side there, and I'm going to draw it up as tight as I can, letting the needle go back in place. If you look in here now, you will see that there is a little ferrule in a small hole, but it's slotted to a larger hole. All we have to do is give it the free play necessary. You simply allow that to come up until you can slide it over and it comes out. And this is what the needle and clip look like in here. That clip should always be below the cup. If you push the needle up and it doesn't push the cup up, you've got it assembled wrong. Before we do anything here, we need to inspect the carburetor boot. The carb boot is the rubber socket here between the carburetor and the intake manifold. If you have dual carbs, of course, you'll have 2 of them. The way you inspect these is you flex them, okay? And I'm seeing some tiny cracks. But you flex it up and down, you flex it back, and you're looking for these cracks. Oh. Right here we've removed the carburetor and gotten it out of the way. And we're going to go back and look for these little cracks I was talking about. They sometimes form under the bands or right where the bands end, which is the case in this particular case. They're hard to see while the bands are on there, but the reason you squeeze it is to open them up. Once that reaches through, it's going to start sucking air. Whenever you start seeing cracks, it's time to replace the boots. This boot is obviously going to be replaced when we put it back on. If you go on around there, you'll notice there's some more. Okay. Another thing you'll notice is there's an arrow on this carburetor boot. The arrow goes towards the engine. That's the flow of fuel. Usually if there's an arrow on a fuel system, it is in the direction of flow. We're moving back over here to the exhaust for a moment. If you notice, that's starting to rust in this joint. Also inside of here, you'll see shiny places where it's metal on metal. You'll see rusty places that obviously it hasn't rubbed lately. These connections should be taken apart yearly, and you should use anti-seize lubricant. We use the silver I think that is what Rotax recommends. And all you're wanting to do, you're not wanting to gob this stuff on there, because if you get it on there too thick, it's going to blow all over the side of your engine. You're just wanting to put a very light coating over the joint. That gives it some grease. You're not putting enough on there that it's going to blow out. But when you put this back together, it's going to give it some lubrication in there. It's going to keep that rust from forming. Again, it's anti-seize lubricant. It's used mainly on places where you install steel into aluminum. The drain plug for the gearbox here is steel into aluminum. When this gearbox is hot, the oil is hot, do not try to remove the drain plug, because steel expands a little larger than aluminum. Okay? Which means you'll never get the plug out until it's cold. If you do get it out, you'll probably bring the aluminum threads out with it, which is going to cause you to have to replace half your gearbox. So it's just a word of warning. You're supposed to use anti-seize lubricant on your spark plugs also. Be careful not to get it on the electrode, because it will short out the plugs. But you just simply put a little bit on the threads and screw them in. Never take a metal, steel fastener out of the aluminum block when the engine is hot. Never retorque your heads when the engine is hot. All that should be done when the engine's down at room temperature. If you notice, these are solid cap plugs. What I mean by a solid cap plug is it doesn't have the aluminum sheath around here that screws on. Okay, these are welded on from the factory. Okay, the aluminum caps with the removable tips you should not use in an aircraft engine for two reasons. Remember, we talked about the cost of these plug caps, close to $20. That aluminum will wear off into the connector in here and will actually cause oxidation to build up in there. Okay, if you look in here and you don't see bright brass, if you see black, you've got oxidation built in there, and it's from old plugs that had the aluminum caps. Had the aluminum caps on them. Do not use those in aircraft engines. These steel caps wear a whole lot slower, virtually none in 25 hours. We have piston pin pulling tools, which this tool alone for the average owner is about $275. Most individual owners don't buy this tool. Okay, to do the job one time, it's just not economical. There's a lot of other smaller tools. This is a tool that's made to put the snap clamps back into both sides of your pistons, the snap rings. They're not called snap rings, they're called circlips, I'm sorry. Whenever I do an engine, I also have a thread chaser. I chase all the carbon out of the threads of the spark plug hole. Otherwise you can start, you know, it can get tight when it shouldn't. Those should all be cleaned out if you're doing a decarb. This is a flywheel removal tool. This tool is over $100. If you knew what the price of a flywheel was, you would never consider using a 3-jaw puller on it. This is the puller that's made for it. This is the puller you should use. If you do tear up your flywheel, I've got new ones in stock. This is a fan fixation tool, which we're getting ready to go to. This is required to fixate the fan so that you can take the big nut loose and fixate this. You shouldn't hold the fan blades, as you'll see in a minute. They are nylon and they're an odd number. If you snap one off, you simply can't cut it off and cut the reciprocal off the other side to balance it. It will never balance because there are an odd number of blades on it. You need all the blades for it to work properly. This is one of the, this is to remove the flywheel off of a C or an E gear drive. This tool here is to remove the drive gear off of a B box and some of the A's. Another thing I would like to talk about just real quickly, we use a parts cleaner. We try to use warm water. We also have our sandblaster down here. We don't use sand. We use plastic beads. Sand will actually take the meat off of your pistons. It will take the meat off of your crankcase, crankshaft bores. This is simply a plastic bead material that will not take metal off. The plastic beads will simply degrade. A lot of times I'm asked by people, how do I clean my air cleaner? And some people make it a lot more complicated than it actually is. Cleaning these is very simple. All you need is either the K&N air filter cleaner or a good quality degreaser. My personal choice, and I'm not advocating the company, is this product right here. It's a good degreaser. It's a mild detergent. You don't want to use anything very hard on this. You never want to use air to clean this filter. A cloth element that's between two layers of screen. There's a layer inside and a layer outside, and when they fold it, it just holds that cloth in there. You don't want to use high pressure air because you can actually blow a hole in the cloth. Then it's no good. You want to use hot water. We're going to make sure the water is hot. Okay, now we pull the plunger, and all we want to do to clean this is we want to clean it from the inside out. So we're simply going to set it there and have the water go inside it and flow out. Along with that, we're going to put our detergent. Just a little bit of Dawn. And if you notice, you'll start to see some color starting to come out of the air cleaner. All we're going to do is fill the water level up to here, because we don't want to allow any dirt that has come out of the filter to float over and get inside. If it does that, when you start the engine, it's going to get sucked down the carburetor. I'm going to add a little bit more Dawn because it's not soaping up real well. And I'm going to lift it up, do a couple, look at the particles come out. But we don't want to let that water get inside here because all those particles, some of those particles are going to go inside. So we've got our water level right to the lip there, which is the top of the filter. We're going to shut it off. All we're going to do is do it this way. That way the water flows into it through the filter, and when you raise it up, it flows back out, bringing the debris out with it. You do this until you're relatively sure that it's clean. You don't want to brush this. You don't want to use acetone on this. You don't want to use anything but a gentle degreaser detergent. But let's assume, okay, that that's clean. We're going to drain our water. because now we're going to do a rinse cycle exactly the same way. We're going to run the water from the inside out. If you see much come out, then we're going to do the wash process again. When you're done rinsing it, you simply find a piece of counter, put down some plastic with some paper towels on it, or just some paper towels on a counter. I mean, it just depends on how much of a mess your wife will allow you to make on your kitchen counter. And you just simply let it dry. Once it's dry, which normally takes overnight to 24 hours, you re-oil it with only K&N air filter oil. Don't use anything else to oil it, because that is the right viscosity to stop dirt particles but allow air to go through. For example, if you sprayed 30 weight oil on this, it would not suck the air through as quickly or as easily as it does with the correct oil. It would have more flow resistance and would actually cause the engine to get rich, because it wouldn't get as much air as it got fuel. So use the right K&N oil to re-oil them. But that's the process. To properly oil this filter, if you look at this filter, it has never been oiled. All you do is you want to spray along each pleat. You don't want to use it in a circular motion. You don't want to go this way. You want to spray straight up and down the pleats. Okay? What you do is you spray straight up and down, and then you set the thing down, because it will wick into parts that aren't covered. You set it down for about 20 minutes and let the oil wick to all the other portions, and then you pick it up and you examine it, and any white spaces, places that we see that are unoiled, you just go back and spot those. So this is an example of how much oil and the proper way to do it. Got it about 3 inches away. I'm going to spray straight up the pleat. Going to go down those pleats. And this stuff comes out pretty fast, so you need to keep your hand moving. You don't want to use it in a circular pattern. Again, just straight up and down the pleats. And it should only be one shot up each pleat. My aim is not that good this morning. But when you come out, when you get done, you want it to look fairly pink. Not bright red, but fairly pink. Got really crooked there. Now if I stand here and just soak it until it covers everything, it will be over-oiled when we get finished. Okay, all we're going to do now is we're just going to set that there. I'm going to clean up my little bit of a mess that I've made here. And in 20 minutes we're going to come back and look at it again. See how it has wicked compared to now. Okay, we're going to come back to our air cleaner. It's been well over 20 minutes now. And we're just going to look at it again. If you notice, it's still not wicked in right there. There is a small area right there that's still kind of white. There's a few small areas, mainly up here near this end of the carburetor. The rest of it, there's a small area there that didn't wick. But all in all, it's pretty well oiled. It's, as you see, it's kind of a purpley pink. What we're going to do at this point is simply go back and re-oil the places that didn't wick in. I'm going to have to hold this over the garbage can, so I'm just going to, again, 3 inches away, just kind of hit those areas. Just brief spurts. You don't want so much oil in it that it won't let air through. Again, I should be going with the down there, missed it a little. Okay. Right there, there's a little light place. I'm just going to go back and hit the spots that didn't get coated. And this time, just to make sure that it wicks evenly, we're going to turn it over so that the oil will run. Okay, in the 503 engine teardown, we fooled with an A-box and an adapter. What I wanted to show you here is just exactly what Provision 8 means. This is a Provision 8 engine. This is the PTO end of it. If you notice the bolt holes for the gearbox, there are 8 of them. Provision 4, guess how many bolt holes there are? 4 of them. A Provision 3, 3 of them. A non-provision, none of them. And there's no bosses to even drill them into. No surface face back here for the sealed. This right here, this surface right here, is where your seal, which is inside your gearbox. But if you notice right here, it's the same as on the A-box. There's a detent that an O-ring goes into that is just about the same size, well, it isn't just about, as this surface, because those two mate together, and that O-ring seals the gearbox oil from coming out. If you notice, there are some screws in the side here that are threaded. These are not to be plugged up. The whole purpose of those is to mount, if you mount the radiator to the PTO end of your engine, the Rotax twin radiators, an adapter goes in there that a rubber bushing attaches to hold your gearbox, your radiators in place. That's the whole purpose of that being in there. If you do close it off, the gear oil that's in here heats this inner cavity and it gets extra hot. So even with the adapters in there, there are little ventilation holes that are drilled through the adapters to allow the pressure to escape. As you heat up air, of course, it builds up pressure. Along with this, you notice that there are provisions in here for how many bolts. 1, 2, 3, 4, 5, 6. So we're not going to use all 8 of these holes, but we are going to use 6 of them. Okay, this is the seal that fits in there. It should be a little bit tight. You want to put some grease in there to just kind of glue it in place until you get it all matched up. You want to make sure when you take your gearbox out that you don't lose that, because that will fall out, and if you lose it, you got to get a new one. The other thing I wanted to show you about the B box as opposed to the early B's and the A's is where the extra screws go. Remember I said it had a provision for 6 of them? This one is set up to go this way because the vent's on the top, but just for the demonstration here, we're going to turn it over. Fits right on there, and 2 of the bolts are internal. So if you pull all your outside bolts and your gearbox will not come off, that is why. Okay. The only service that's really required on this gearbox, on a B gearbox, is that once every 100 hours you need to replace these beveled washers. These are actually called spring washers because they fit together and they're placed in there like so, with the bevels apart from each other. And as you squeeze in, it creates a spring load. And those are, there's more than that, there's 12 by the way. Those are underneath here. And their whole purpose is to put a spring load on the back of this gear to hold the shaft in place and keep everything tight. They're held in place. This tool, or a tool very similar, this is the Rotax tool. And it fits right on here. You put this face on a surface with a hole in it, of course, because you got your prop flange sticking out there. And you take your press and you push down, and if you notice, you can see this one is split. There's two keepers in there, much like the keepers on valve on your automobile valves. Okay, you depress that down, that ring goes down, that's a retaining ring, and those two pieces separate out. You take them out, release the pressure, and the gear will come off. Okay, below that are the shims, which again need to be replaced. If you're hearing your gearbox clatter, those, and you got a B box on it, if you're hearing it, a metallic clatter is what I call it, the shims need to be replaced. B boxes are the most under-maintained items out there. You can run into a 10-year-old B box that have probably never had the shims changed. It will be very obvious if you know what you're listening for, because it will make a lot of racket. The gearbox has a drain plug on the bottom and a filler cap with a vent in it on the top. Okay, of course when you want to drain it, you drain it out of the bottom. I'm going to show you this new one because I don't know from the last engine teardown if you really got a picture, but if you notice, that is simply a magnet sitting in a recess. That's a magnet. It's made to collect gear particles as the gears wear in. Any metal particles get attracted to that, and they will actually fill this recess, and it would just look like there's black rubber in the bottom of here. But it all should be cleaned out with, alcohol or gasoline or carb cleaner after you clean it out by hand, with a screwdriver and a rag. You want to get all that stuff out, and you want your plug to look like that when you put it back in. The interesting thing, and the next thing I want to show you is how high do I fill my gearbox? Let's say that your gearbox is mounted this way. If you'll notice, there's two screws inside. The purpose of these two screws is they are your filler marks. Whichever one's on the bottom is the mark you use. If this gearbox were mounted in this position, you would take this out, fill it with GL 5 or 6, 185 to 140, and you will fill it till it comes out this hole. Okay? And that's just in there with a screwdriver. And if you notice, it has holes in it. These should be wire tied together. If you were to be using it in its other application, which is turned up, you would simply reverse the drain and the vent. The vent would be up here, the drain would be on the bottom, and you would use the lower hole, which is right here. Fill it up to there. All the gearboxes are made this way, or all the Provision 8 gearboxes are made this way. And that's the purpose of the 2 screws. That's your fill mark, depending on how you have it mounted. I've recently started carrying the newer style exhaust clamps, the stainless steel kind that don't use the hooks or the traditional springs. So far, what I've seen I really like about them. Early models did not have this brass bushing in here. All the brass bushing is for is to give the bolt a brass surface to flex instead of the bolts rubbing through the stainless steel, which was wearing off the sidewalls of the bolt. That was an issue early on. Since they've gone to the oilite bushings, brass bushings, there has been no more wear. It's not even an issue anymore. This is a complete set. The whole kit. You get 4 flanges, 4 springs, all the brass inserts, your bolts, the bolts that hold the two halves together, along with all the nuts you need. You should not screw this down so that you close up the spring. If you do that, you might as well have just put a hard bolt through here and left the spring off, a shorter bolt, because it won't allow it to flex. It'll get so tight that's it. And you want this to flex in flight if the muffler has to move or something has to move. The reason they actually went to a 3, the early engines had an exhaust manifold that looked like this. It was welded or made as one piece like this. They did away with that because they found that mufflers were cracking. They needed more flexibility in the muffler system. So what they did was they went to an elbow that fits on here. Okay, it did away with most of the cracking of the exhaust systems, but it added a couple extra springs, 3 extra springs in the deal for traditional springs, or 1 extra clamp. To do your entire exhaust system, you need 2 sets. This set here is exactly what you see right here. It's enough to do 1 joint. So remember, you need, if you're going to switch to these, you need 2 sets, 1 for each joint. On the modern Ducati ignitions, you must have at least 300 RPM before the spark plugs will fire. If you have a broken rope, the shorter it is, the harder and harder it is to reach 300 RPM to produce a spark. So I thought it would be good to show everybody how to replace the rope. It's not really that mind-boggling once you've seen it done. But I, like everybody else, before I knew how to do it, was terrified of them, because all you think about is the springs flying everywhere. Should use snap ring pliers here, but we're not doing it. to get that off. Came off very easily. Set it there, we don't want to lose it. The next thing that comes off is this metal clip, and all you have to do is unwind it a little and work it off. The next thing is just it's called an E-clip, and that E-clip is very simple to take off. Get my bigger screwdriver. It just simply pops out.
Fantastic, that's great.
Okay, the next components, these two can come out separately, but they're actually a unit, so I usually leave them together. You want to lay that down there, and right here is the lock that keeps your rope in there. What we're trying to do here is pull all the rope out. And that is it. To give you all a better view of this, we're going to tilt it up here. I'm going to try to turn it for you. And to take your rope out, you simply grab the loose end there with a pair of needle nose pliers. You pull on it, and that pawl, which is what it's called, will simply slide back. Once it slides back, it will pop out. The long point always goes towards the way you're trying to stop it from going. And it wedges in that hole and keeps pressing tighter against the rope to lock it in there. But again, that's all there is to taking the rope loose. And we're going to completely remove it, just like if it was a broken rope. It's completely off of the thing. You want to wind your recoil up again so it's just about tight. Okay, you want to line those two holes up with this inlet hole. You just feed it straight in there, let it go all the way across, turn the pawl towards the end of the rope you want to jam, and simply put it in the middle here. Then pull the rope, and it will pull that in there tight. You want to make sure it stays down, that the rope's under it well. Okay? And you simply, holding your finger there and holding the rope, let it go in. Now, if this were just a plain rope, it probably wouldn't have the handle on it yet, and all you would do is make a pull knot, what I call them, to keep your rope from going in there and just winding up. Then you work with putting your handle. Okay, at this stage we're done with putting a new rope in. We start putting the parts back on it. If you notice, this has a tab hanging down, a round plug, and it goes in that round hole. We forgot to put the big clip on there, which goes underneath that. Just snaps in place, and that holds everything on now. Nothing can come off. Then we put our clip on with, again, that peg right there going through here, and you want to rotate it so it gets larger and fits down over there. Okay, and this doesn't normally come off, so let's just make sure everything is going to work properly. As you pull it, it moves this out to engage the starter cup that's inside there. See it move in and out? And as you let it back in, it pulls it back into a neutral position. Okay, we don't want to forget our last little piece, which is this circlip. Not circlip. It goes on very simple. It's not a high spring. You want to spin it around a little bit, make sure that it's in the groove properly, and we have our recoil. Replace the rope. Another thing I'm going to real quickly talk about here is the 582 Bluehead recoil starters. This was such an improvement because of the larger diameter. It's easier to pull. It works the same general way. The big difference here is you don't have to take it all apart to get to the pawl. The pawl is right there exposed. But you do it the same way. You pull it all the way out, you line it up, you push it through, you put the pawl back in, and it's done. One reason they did that is that this doesn't come apart. This has a one-way press-on pin. If you pull it off, it actually runs it's metal, and it runs those tabs that hold it on. But again, the main reason I wanted to mention this to you is the fact that this will fit perfectly onto the older Silverhead engines. It does make them a lot easier to start if you're using a recoil starter.